Hi everyone, it's Mrs. Willenbrock, your favorite COVID-infected math teacher, here to talk to you about an application of antiderivatives, which is talking about the concept of marginals in economics, specifically marginal cost, marginal profit. Now, let's write this down. We are going to talk. If we are, let's get a pen. Okay, if I want to talk about marginal cost, by definition, that's a function that represents how cost is changing. Okay, and so one way to write that would be if C is our cost function. This is, remember I told you we were going to get confused because we were going to throw C back in the mix. If C was our cost function, then C prime, or sometimes we'll see it written this way, is the marginal cost. It's a function that measures how the cost is changing, how the cost is increasing or decreasing at X items. If we can measure that change, the antiderivative of that cost function, of that marginal cost, will give me my cost function. So if I can collect information on how costs are changing given different conditions, I can then predict, I can create a function to model my costs in a variety of scenarios. Okay. So let's take a look at that in a specific example. So the first thing we'll be given is a marginal cost function. So let's say we're told that we have a marginal cost function dc dx of 32 minus 0.04x. X is the number of items produced. Okay. And let's say we also know the cost to produce one item is $50. Find the cost to produce 200. Now, here's the interesting thing. Because in reality, every item's cost is not equivalent, hence this cost function. The overall cost is going to depend on the number of items, not in a straightforward way. If you say, well, $50 per item, 200 items, 50 times 200. Okay. But that might not be the case. The first item might be $50. And actually what this is telling me is that the costs are changing. They're actually decreasing. If you look at this and realize that this would be a line with a negative slope, that as you put in bigger and bigger and bigger and bigger x's, your change in your cost will be going down. Okay. It's more efficient to make 10 items than one item. You still have to pay for the materials, but maybe the labor costs are different. So since we have a varying relationship in our costs, in order to figure out the final cost for 200 items, let's see if we can come up with a cost function overall. Okay, and the way we're going to do that is we're going to take the antiderivative of our marginal cost. Now, our marginal cost function is a nice, fun, linear function. We're going to take the antiderivative of both terms. We're going to use our tricky backward power rule fun stuff. So antiderivative of 32 would be 32x minus 0.04x squared divided by 2 plus k. I am switching letters on you. I'm sorry, because we are dealing with a cost function. We tend to roll into a new number to represent the unknown constant. Okay. So my cost function is 32x minus 0.02x squared plus some mystery k. Now, how do we find k? We use what's called the initial, and a given condition, a piece of information. That piece of information, we were told at the beginning that the cost for one item was $50. That means that C of 1, or 32 times 1, minus 0.02 times 1 squared, plus k, should equal $50. So 32 minus, if I square 1, I get 1 times 0.02 is 0.02 plus k equals 50. Oops, it doesn't equal k. This is Willenbrock, it equals 50. Okay, I'm going to grab my calculator so I don't do anything bonehead. And so this is going to be, and I'm double checking myself over here. Why am I getting... What did I do wrong? Nothing. Hang on. Oh, because then I'm going to subtract that from 50. I was like, that answer looks really weird. Okay, so this is 31.98 plus k. Sorry, guys. Doing my best. And so if I take 50 minus 31.98 minus 31.98, 31.98 minus, I get 1802. So that means my cost function, if I go back to my antiderivative, is 32x minus 0.02x squared plus 1802. So that means if I want to know the cost of 200 items, I substitute 200 in for x, which I'm going to write that down, but then I'm going to grab my calculator and crunchez-vous those numbers, which I have done ahead of time, and I'm going to get $5,618.02. The only thing that's new is the context. That your derivative represents something, change in cost. So then your antiderivative becomes a generic cost function with a missing number. Using the given information or initial condition information, starting information, whatever you want to call it, we find the missing constant number. So we can write a generic cost function so we can calculate a given cost. The process would be the same regardless of whether this was marginal cost, marginal revenue, marginal profit. They all work the same way. If we are looking at dc dx, that would be marginal cost, like we just talked about, and taking the antiderivative of that with respect of x, it would be the cost function. And similar dp dx for marginal profit, which we can find a profit, and dr dx for marginal revenue. Okay, you're going to practice each one of these on a very, very short assignment from the textbook that I will link into Schoology. That assignment, as well as pulling all the pieces of your project together and getting that turned in, are your two main assignments for today. All right. Thank you. Hope you have a wonderful day.